Good morning friends. Today in this video we will discuss about k-means algorithm in machine learning. K-means is a popular unsupervised machine learning algorithm which is also known as k-means clustering technique. This means that k-means algorithm can classify data on its own without explicit labeling. This is an Euclidean distance-based algorithm which tries to group those data points together which are closer with each other. K-means is an unsupervised type machine learning algorithm which tries to find hidden clusters within data distribution in order to classify them. As we know, unsupervised learning doesn't have significant training phase, rather it takes entire dataset inside its memory to do classification. In this algorithm, we assume number of clusters that are present in it and we denote it with k. K is the assumed number of clusters. Sometimes we know data very well and know about hidden clusters present in it. Sometimes we use our sense of judgment and sometimes it is entirely on trial and error basis. But in any ways, setting the best value of k is important. Once done with this, algorithm is good to go. Algorithm assumes k number of centers and then tries to find closest point with respect to these centers. This is done in several iterations till we get most stable cluster. Let's understand this with an example. This is our data distribution that need to be classified. I have already shown classification using different colors so that we can understand how algorithm is correcting clusters during each iteration. In practice, we don't have any idea which point belongs to which cluster. Algorithm randomly selects k number of centers or centroids. In my case, k is 3. Choosing value of k is experience based and we need to choose a value which gives you most optimized output. Here I am choosing k as 3. This means pick 3 centers randomly, which is center 1, center 2 and center 3. Now pick each data point one by one and find the Euclidean distance with each of these centers and assign the point to closest center. Consider each center represent each cluster. As per our example, suppose we pick this point which is denoted as P1 and we find Euclidean distance from P1 to center 1, center 2 and center 3 respectively. Distance with center 1 is least, therefore point P1 belong to center 1. Same steps will be repeated for each and every point and finally we will be able to assign each point to one center and this will divide our dataset in 3 clusters and one iteration is finished here. Now, let's begin the second iteration. In first iteration, we assumed 3 random centers, but this time we already have 3 clusters. Therefore, instead of 3 assumed centers, we consider centroid of each cluster as center and rest of the process will be same. Reason why we took random centers because we had no idea of any clusters. So, just to start with, we did that. As far as centroids are concerned, this is the same centroid that we study in statistics, which also represent center of gravity of distribution. Since we are working with data with many features, therefore its mathematical expression will consider all features, which will make expression somewhat complex. And I am not going to explain centroid topic here, as they will change the discourse of discussion to entire other direction. If you want a video on centroid, please comment and let me know, or else you can explore yourself anytime. It's very common topic. Coming back to iteration 2, find the centroid of each cluster and make them new centers, which is C1 new, C2 new and C3 new respectively. These are our new centroids and repeat the same what we did earlier. and assign each point to nearest center. This time we will observe few points will leave the existing group while other new points will join the group. In our example, we can see P1 and P2, which is currently with cluster 1, will join cluster 2 as they are closer with C2 new. With this, we can clearly see three clusters with new configuration. P1 and P2 are now part of cluster 2. We can see that in each iteration, algorithm is correcting itself. With this iteration, 2 ends and the final state is shown in diagram. Let's begin third iteration with same steps what we did in iteration 2. Again, we will calculate new centroids, consider them new centers. We will find the closest centers and reassign the points to the closest center. Suppose this time new clusters are C1, C2 and C3. We can see in iteration no point is leaving their existing centers. This means we found the most optimized state. This is the iteration where we need to stop and consider this a final state. Points that are in same clusters are considered to be in same classification. Also, you can note that even we don't stop here, since clusters are not changing their centroids, clusters will also be exactly same each time, which will automatically make further iteration meaningless. One more important thing to note is, here for ease of understanding, I have shown 3 iterations, but in reality, number of iteration may increase to any numbers before you get optimal result. As number of iterations increase, computation power will increase. So at some point, you may decide to try different values of k, so that number of iteration can decrease. What value of k will give best performance and accuracy will entirely depend upon how data is distributed and how clearly clusters are present in it. Value of k is a subject of experience and sense of judgment. As we know, this algorithm is very simple, which make it fast, robust and understandable. Since this uses Euclidean distance as the basis of classification, this gives best result when data sets are distinct and well separated, whereas they tend to perform poor when data are overlapping. So far we have seen how it works. Now let's discuss what are the areas they are used most. They are used in finding behavioral pattern of certain activities, dividing inventory data into categories, finding unusual activities, which is also called anomaly detection, and classifying digital data like photos, video, music, etc. When we purchase online on e-commerce website or in malls, they maintain purchase history of each customer, phone number wise or email address wise. Now k-means can be used to identify what kind of product certain customer purchases or he may be interested in future. They categorize this data in many ways and output they link with each customer, like so and so customer is frequent visitor, so and so customer prefer credit cards, so and so customer prefer mobile app over website, and many more. This is called profiling customer data. They also store your activity time and duration of browsing, what kind of product you browse, what is the percentage that you order a particular product after browsing, and many more. K-means is also used in inventory classification so that similar products can be stored together in same warehouse. For example, one can use k-means to know what are the products that are sold together so that they can be stored together to avoid unnecessary movements. For example, people who buy air conditioners, they also buy voltage stabilizers. If this fact is known, then they can be stored together so that they can be delivered from a single warehouse only. Similarly, things that can be used together during manufacturing process can be stored together to avoid any unnecessary movements. K-means algorithm is used to explore unusual activities like fraudulent transactions or finding invalid clicks. K-means is also used to categorize image, music and video kind of digital content based on topics, user interest, user trends, etc. I hope I be successful in explaining important facts about K-means. If you want some more information on this topic, please let me know. Thanks for visiting my channel and thanks for listening to me. Have a good day. See you in next video. Thank you.